dy is greater than or equal to delta y?
We don't know.
Are they not equal to each other?
That is correct, but that's correct. But I don't want to use it. There is another one that is better. But you are correct. They cannot be the same for sure. Absolutely, no question. So
delta y is equal to dy?
cannot be.
Approximately.
Yes. They have to be so close. They have to be so close that they are approximately the same. Very close. Excellent. So now, this is the final concept. Once we understand that they have to be very close, remember this definition. F of x plus dx minus f of x, approximately. Remember this definition, you just gave it to me. F prime of x dx. So, of course, I'm going to do this. And I have f of x plus dx approximately f of x plus f prime of x dx. Super important relationship. How did we get it? We built this. We saw that they have to be approximate. They have to be almost the same, but not equal. We have the definition of this. We have the definition of this. And the question is, how do I use this concept? How do I use this? Okay, so now let's see how we use it. So let's start with an example. Okay, a simple situation. Let's say problem. So again, this tells us that I can determine the exact change in a function by simply multiplying these two quantities. If I'm happy with an approximation, I will not do this. If I want the exact, I have no choice. I have to do this. But if I'm happy with an approximation, this will always be easier, not better, easier to calculate than this one. Okay. So let's start simple with an example like, let's say, problem 7 on page 341. Okay, we're given a function f of x equals 3x minus 1. They're telling us that x equals 4. They're telling us that delta x is negative 2. And they want part A. They want delta y. In part B, they want dy. In part C, dy for the given x. No, C is the same with B. There is no need. Okay. So how do I determine delta y? Well, delta y has the definition. We know f of x plus dx or delta x is the same thing. Plus dx minus f of x. Okay. Here is my x. When I determine f of x is basically I determine f of 4. When I determine f of x plus dx or delta x, what will I determine? F of anyone? F of what? Anyone would like to try? F of what? What am I trying to determine here? F of
X, 3x minus 1.
x is 4. Dx is negative 2. So then I'm determining f of Good, awesome. That's all I need. So then f of 2 will be 6 minus 1, which is 5, minus f of 4, which is 12 minus 1, which is 11. And then 5 minus 11 is negative 6. So that was delta y. Now they want us to find dy. But we know that dy is, by definition, f prime of x dx. I have to find f prime first before I find f prime of 4. So can anyone give us f prime of x for this function?
Is it just 3?
That's it. So I don't have anything to plug in anything, right? So then I will continue with dy equals 3 times dx. dx is negative 2. And look at that. Okay, before I continue with the next problem, I just want us to understand the difference between derivative of f of x versus differential of f of x. And then we'll continue with the next problem. Okay. So for a function f of x, can anyone tell us how do we write the derivative? I know it's a silly question. I just want you. That's it, of course. For f prime of x, for f of x, can anyone tell us how to write the differential?
Delta x?
That's the differential.
Delta y.
dy equals f prime of x dx. So please understand the difference between the two. This one is asking us to find the function that gives us the slope of the tangent line at any point where the function is differentiable. When we're asked to determine the differential of a function, we are asked to find dy, and we have to multiply f prime of x by dx. Okay? So please understand this concept. This is huge because I need this for chapter 4. Okay, so here's another example. Let's say problem 17, another application of what we just discussed. The cube root of 1005. And you can say, what are you trying to do? I am trying to use calculus. Basically, that's the question. Use calculus to approximate. I emphasize approximate. The cube root of 1005. And you could say, what is this? And then I'll say, it's this. Okay, I'm going to copy it right here. F of x plus a little bit of error is approximately f of x plus f prime of x dx. We know where it's coming from. We looked at the graph. We know those are approximately the same, and I moved f of x to the other side. So, okay, so you can say, what is this? How is this connected to that? Very simple. This is what we are asked to work on. The cube root of 1005. But I cannot determine this part before I identify f of x, I identify x, I identify the error, which could be positive or negative, and then I calculate f prime of x. Once I have these pieces, the rest is a piece of cake. I put in here, I put in here, I put in here, and calculate. So looking at this, can anyone identify the function that we are dealing with? Anyone? Which function are we talking about? Is it e to the x? Is it natural log? Is it rational? Is it absolute value? What is it?
That could be simplified to a rational function.
Let's take a look. What function is it? I don't see a ratio. If I see a ratio, like 1 over x, then I have to say rational. But I don't see a ratio. Looking here,
It's the exponential.
I don't see the exponential. The exponential function will be something like a base to x or e to x. I don't see this, I don't see this, I don't see this.
That's a radical, but can it not be simplified to a
No, I'm not.
exponential?
I can't simplify anything. I need to identify the function. So when you look here, I just covered this piece. What function do you see?
Are you saying it's a cube function?
That's it. That's what I see. It's the cube root of x. There is no 1 over x. There is no exponential. There is no log. I don't see the square root. I don't see absolute value. I definitely, when I read this, I have to say the cube root of blah, blah, blah. I don't say 1 over. I don't say 5 to x. I don't say any of that, right? That's why I covered it, to give you a hint. When I read this, I have to say the cube root, right? So that's our function. Perfect. So this is the same with x to 1/3. I can find the derivative. I bring down 1/3. I have x to 1/3 minus 1. So this is negative 2/3. Good. Now let's identify x. Let's identify the error. What do you think x would be? Now I'm looking at the number. Now I'm looking here to identify x and identify dx. X is a number that I can take the cube root from, easy, and dx is the error. What do you think x is?
X is 1005.
It cannot be, because if this is 1005, then what is dx? 0? It cannot be 0. So look at 1005 and say, I think x is this number because I can take the cube root from it very easy.
Approximately 10.
We are talking about what we plug in this function. So this quantity is 1005. I need to identify x and the little error. If the sum is 1005, what do you think x would be and the error would be?
X be 1,000.
Of course. And the error is a tiny error. How come tiny? Yes, tiny, tiny, error, tiny. If this is 1,000, I'm a little bit to the right to 1005. My error is tiny, is 5.
Professor,
Yes?
so couldn't it also be, I don't know, 1,002 or something like that, and the error?
I cannot take the cube root from it. I need something that I can work with easy. And
Okay.
so that I can't go to 900 because then the error is 105. It's not
Okay.
acceptable because these two numbers then will not be close. Good, it's done. So here, this is a legitimate equal symbol. This one cannot be equal, but this one is legitimate. F of x, when x is 1,000, how much is f of x? And I'll put it in. X is 1,000. What will be f of x?
10.
That's it. Plus the derivative, 1 divided by 3, and remember this is the cube root. I have to plug in 1,000 and square it, times dx. So this is here, this is this piece, and now I want dx. What did we say dx was?
5.
That's it. You had no idea that you can take the cube root of this and get something very simple. 10 plus, the cube root of 1,000 is 10, but I have 2 of those, so over 300. And I simplify by 5, and I get 60. So this is 601 over 60. You had no idea that using calculus, you are able to approximate the cube root of, and I'm stopping right now. I know it's time. I just want to show you. So let's take the cube root of 1,005. See how powerful you are? 1 divided by 3, the cube root. This is the exact, and this is the 601 with calculus over 60. Are you proud of yourselves?